Now we'll see an example problem which is based on proving or disproving whether a function is differentiable at a given point or not. So in the previous video we discussed that if a function has to be differentiable, then what is the condition? Then the left hand derivative should be equal to that is, for a function to be differentiable, left hand derivative should be equal to right hand derivative should be equal to f dash of c. If all the conditions are satisfied, yes, we can say that the given function is differentiable at the point c. Here we need to prove that mod x is not differentiable. So as I told you, every differentiable function should be continuous. First thing, before you check the differentiability, the first thing you need to validate is you need to verify whether the given function is continuous or not. So we know that mod x, yes, it is a continuous function. So this we have discussed in previous exercise itself. So it is a continuous function. Now for checking the differentiability, I am considering the left hand derivative. Let's see the proof or the solution. So left hand derivative is limit h tends to 0 f of c minus f of c minus h divided by h, right? So this is going to be like this, limit h tends to 0. Here what is c? F of 0 minus f of 0 minus h divided by h. This is equal to limit h tends to 0. So what is f of 0? If you substitute 0 here, mod 0 is going to be 0 minus of, if you substitute 0 minus h, the value of x inside modulus is less than 0, then the output is minus x, right? So here what will happen is, so observe, mod of 0 minus h will be equal to mod of minus h, which will be h only. So here it is going to be h divided by h, right? So it will be limit x h tends to 0, 0 minus h, sorry, 0 minus h is going to be minus h divided by h, that is limit h tends to 0, it is going to be minus 1, answer is minus 1. So left hand derivative is minus 1, the right hand derivative is limit h tends to 0, you will have f of c plus h minus f of c divided by h. So this will be limit h tends to 0, f of c plus h means f of 0 plus h minus f of 0 whole divided by h. So f of 0 plus h is going to be h only, minus f of 0 is 0 divided by h. So this will be limit h tends to 0, h by h is going to be 1. So answer is 1. So right hand derivative. From this we can conclude that since left hand derivative is not equal to right hand derivative, the given function mod x is not differentiable at x equal to 0. So this is the proof. So what you can do is, in your exam for CBSE, you can stop with this. Now I'll explain a different way of visualizing this. Try to understand. This is only for your understanding. You need not apply it in the exam. So as I told you previously, differentiation is done to find the differentiation is to find slope of a given line. Slope of a tangent, slope of tangent to the curve at a particular point. So if you have a curve, what you need to do is you need to see the meaning of it is visualize it. If at all you have a curve, if I need to find the derivative of this curve at this point, it means you are drawing a tangent to this curve and you are going to find its slope. So what do you mean by slope? Slope is nothing but the angle, the tangent of the angle made by that particular line with the x-axis in positive direction, that is in the anti-clockwise direction. So tan theta is what we need to find for a given curve. That is, for a given curve you will draw a tangent and you will find tan theta to the of that particular line at the given point, right? Now with respect to this question, if at all you have f of x is equal to mod x, then at x is equal to 0 we need to find the tangents. That is a given point here, right, according to the question. So what we are going to do here is we will draw the curve, or we will represent the function graphically. We know this is the graph for mod x, right? So this is the graph for mod x. This will be x and this will be y. Now if it is a curve, you are going to draw a tangent, but if it is a straight line, you can directly find the tangent because slope is defined only for a straight line. Okay. So this part of the curve is y is equal to x, this is y is equal to minus x. So this is a point C, try to visualize it here. So when you are approaching the curve from the right hand side, that is when you are finding the right derivative, you are taking this curve into consideration. So if I take the value of theta here, what is the value of theta? It is going to be 45 degrees. Right, this is a known fact because y is equal to x, when I compare it with y is equal to mx, what is the value of m? M is going to be 1. So that is the slope of this is 1. So this m is equal to 1 is mathematically, according to the straight line concept, the same m is equal to 1 is nothing but the right hand derivative with respect to differentiation. That is why if you observe, we got the answer as 1 here. When we did the right hand derivative, the answer came out as 1. Similarly, when you are doing the left hand derivative, you are going to take this curve. So here if you observe y is equal to minus x means when you compare it with y is equal to mx, m is equal to minus 1. This is the left hand derivative. Hence this angle will be 135 because tan theta is equal to minus 1, theta is 135 degrees. So when you are doing it, the left hand derivative comes out to be minus 1. Right. So that is why if you observe, for the same question, when you are taking the right hand slope, it is coming out as plus 1. When you are taking the left hand slope, it is coming out as minus 1. So this is the meaning of right hand derivative and left hand derivative. So you can directly look at the graph and see. Okay, if at all you are able to draw the graph for all the functions, I am not saying it is easy for all the functions. If at all that particular function you are able to draw a graph, then you can draw the tangents at that particular point and conclude whether it is going to be differentiable at that point or not. By looking at the graph, we can say here the slope is different, here the slope is different, hence it is not differentiable. So I am repeating it, this method need not be used in the exam, it is only for you to visualize how to find the derivatives using graphical method.